In your notes, please write this down, or on your desk. Step 1 is always find the length of the period. And so I'm going to do that off to the side here. And I'm going to abbreviate just for space reasons. How do we find the length of the period? And what the length of the period means is after 4 steps, what is the horizontal length it takes to do 1 cycle? Now to find that, we always take 2 pi and we divide it by whatever is stuck with the x. Now it's really easy for students to say, well, isn't there a 3 stuck with the x? But in this case, it's actually a 1/3. So underneath this, I'm going to write 1 divided by 3. And if you can do the mental math, awesome. If not, grab that calculator. And we are going to omit, or we're going to leave out the pi symbol. We're going to take 2 and divide it by 1/3. Press enter, and we can see we get an answer of 6. So 6 pi, this is the length of 1 cycle. So I'm going to grab my pen. I'm going to do 4 steps to the right, and then I get to write down 6 pi. 1, 2, 3, 4. Remember that sine, cosine, and eventually we'll learn about tangent are all 4 steps. All 4 steps. All right. Now we need to figure out what is the distance from one step to the next, because it's all equal distances. Now that's going to be determined by identifying the x scale. Identifying the x scale. How do we identify the x scale? That's step number 2. The x scale is determined by taking the length of the period, and we're always going to divide it by 4. Why are we dividing it by 4? Because every sine, cosine, tangent always has 4 steps. 1, 2, 3, and 4. Okay, well this can be reduced. Now if you're not great with reducing, you're always welcome to omit the pi, go 6 divided by 4, hit math fraction, enter, enter, and we can see that this is going to reduce to 3 pi over 2. A lot of students are able to achieve those 2 values, but again, they don't remember what it actually refers to on the graph. Period length is after 4 steps, what is the horizontal length to do 4 steps of that 1 cycle. Your x scale is going to be the horizontal distance from 1 step to the next. So this is 3 pi over 2. Now the beautiful part about using a calculator is that from this point forward, I'm not going to stress about fractions. So I'm going on to step number 2. Step number 2, I'm going to omit the pi symbol, and I'm going to take 2 times 3 halves, and it is 3, so 3 pi. This is step 4. 4 times 3 halves. Oh, I must have done something wrong. Let's go back here. This is step 1. I must have done something wrong. Hold up here, please. 3 halves. So step 2 and 3 halves is 3 pi. And then this is going to be step 3. 3 times 3 halves. Turning it back in is 9 halves with the pi. And then we can see step 4. And I'm going to have you, as quickly as possible, I want you right now to do steps 5, 6, 7, and 8 and have it down on your graph. Whether you're putting this on paper or doing it on the desk, totally up to you. I'm going to do the same. Good morning, Byron. As you're doing this, it's okay if you're not done, but here's my question for you. On a scale from 1 to 5, how confident are you using a calculator to determine the period length, the x scale, and if time is not a factor, and to go through and to label 8 steps to the left and 4 steps to the right, 1 through 5. If time's not a factor, where do we stand? Okay. All right. The next thing we're going to do, so we're moving on right now, we've done step 1, 2, and 3, is I'm going to make a chart, and I'm going to teach you how to cheat. You ready? So let's make a T-chart right now. And we're going to have inputs and outputs here. Your inputs will be steps 0 through 4. So here's step 0, 1, 2, 3, and 4. Steps 0 through 4. And now it's time to learn how to cheat. So I'm going to have you turn to the person next to you. They may or may not have been your previous partner based on absences today. And using your arm, you ready? Using your arm. Look up here, please, right now. I will use my hand for the video's sake. If I said to you, what shape does a quadratic function make? You'd say, okay, it makes like this parabola or U-shape, and either can go up or it could go down. And if I said to you, what about linear lines? Okay, well, linear lines, right? A lot of times they're on a diagonal, right? They're like this. Okay, using your arm right now, how would you describe the two different ways that you know one cycle of a sine function can look like? Turn to your partner. Use your arms. What do they look like? Go. Turn to your partner, look in the eyes. What does it look like? So I would describe it like this. I'm going to use the words hill and valley. There can be a hill and then a valley, or there can be a what? A valley and then a hill. Got that? So if you're unsure of that, you're going to write that down. We have a hill, valley, or we have a valley hill. Now, knowing that fact for sine functions is going to allow you to cheat. I'm giving you permission to cheat on this. Okay, we're going to get started. Here we go. So I need to do only 2. So we have 5 different things. And then once we do 5, we just have to repeat it to the right and repeat it to the left. Here's where I'm going to let you cheat. We only have to do 2, and then we have to make an accurate prediction. So I'm going to start with 0. I'm going to write this down. Please do the same. Y equals negative 5 halves times the sine. I'm going to put a 1/3, and then in back of it, I'm going to put a blank spot. That blank spot is where I'm going to put the first input, which is 0. I'm going to write it really lightly so I can go over the top and put a different number later on. I'm just being lazy. This is my first input. 0 times 1/3 is 0. So I want to go onto the unit circle, and I want to find sine, or I want to find 0, and go, what is the sine at 0? So let me zoom in right now, and I want to locate 0. This is 0, or 0 pi, and I want to say, what is the sine? Well, the sine is the second number. We can see the sine at 0 is 0. So this portion equals 0. This portion right here equals 0. By the way, negative 5 divided by 2 is equivalent to negative 2.5 if you prefer an equivalent decimal. What is negative 2.5 times 0? It is 0. So there's my first step, and I'm going to come over here and do 0, 0. Okay, let's do 3 halves. Now here's where I'm going to be lazy. You ready? I'm going to come over the top and write 3 pi over 2. My first step is going to be to take this portion and simplify it. 1 times 3 is 3. 3 times 2 is 6. Now, if you could simplify that in your head, that's my desired option for you. But if you're not comfortable, omit the pi symbol, and 3 divided by 6, math fraction, enter, enter, we get 1/2. So I want to know, if I come over here, what is the sine at 1/2 pi? So can everybody please go on your unit circle? 1/2 pi is the same as pi divided by 2. 1/2 pi is the same as pi divided by 2. So here is where pi divided by 2 is. And I want to know, what is the sine? The first number is cosine. The second number is sine. So the value is 1. So I come back here. I evaluate this and I get a 1. What is 1 times negative 5 halves? Use the calculator if you need to. I know that negative 5 halves is negative 2.5. So negative 2.5 times 1 is negative 2.5. Okay, ready? Let's try to be as accurate as possible. Let's come up here. This, remember, is y equals. That describes how far above or below the x-axis we need to go at a particular value. So I just plugged in 3 halves, and I need to drop down negative 2.5. Here's 1, 2, 3. So here's negative 2.5. This is negative 2.5. All right. Between you and your partner, I want you to decide who's taller and who's shorter. You have 3 seconds. Taller person, raise their hand. Okay, taller person, turn to your partner. How can we now cheat to determine steps 2, 3, and 4? Go. Tell your partner, how can we cheat? Don't do it, but let's just talk about it. So here we go. Because it goes down first, I'm going to connect the dots. Because it goes down first, I know it's going to be a valley, and then a hill. So I know it goes down, and then back up because I know patterns. And now, instead of going down 2.5, we're going to go up 2.5. So my third step is up 2.5, and then my fourth step ends at the x-axis. So I'm going to come down here. That's me cheating. And I go 0, 2.5, and 0. Now, I would like you on your paper or on the board to now continue that. Do one more cycle to the right and one more cycle to the left. Please be as accurate as possible. Aaron, you can look at my graph or you can look at the graph in front of you. If I asked you to evaluate this function without a calculator, but using this graph at 3 pi over 2, what would be the outcome? Negative 2.5. Thank you. Adriel, can you please evaluate for me at 9 pi over 2?
Be at positive 2.5.
Okay. Luis, can you please evaluate for me at 6 pi?
0.
0. Byron, can you evaluate for me at negative 3 pi? 0. Yeah, you got it. So how do we jump into graphing cosine of x? Cosine of x is going to make a slightly different shape, and we're either going to talk about a hill, valley, hill as the pattern, or a valley, hill, valley. You'll understand it once we get going. So the very first thing I'm going to do is I'm going to identify the period length. I take 2 pi and I divide it by whatever is stuck in front of the x. You may be saying, but there's nothing in front of the x. It's a hidden 1. So 2 pi divided by 1 is simply 2 pi. Now, how do I find the x scale? This is done in the same fashion that we do for sine functions. I take whatever the period or period length is, I divide it by 4. So 2 pi divided by 4 simplifies to 1/2 pi. What does that mean? Same thing as sine. It means if I do 4 steps, step 1, 2, 3, and 4, that's going to be 1 cycle, and it's going to be a length horizontally of 2 pi. Now, each of these steps has a distance of 1/2 pi, or pi over 2. So I'm going to do this right now. I'm going to take this. I would like you to start numbering these if you haven't done so. So just like we did for sine, this is my second step. And I'm going to omit the pi and take it times 1/2. You can see I get 1, and then I attach a pi. Now this is going to be my third step. I take it times 1/2. Again, omit the pi, turn it back into a fraction, and now I'm going to go quick. 3/2 pi. This ends up being 4 pi over 2. This is 5 pi over 2. This is 3 pi, 4 pi, 7 pi over 2. And just like we did with sine, I'm now going to copy them off to the other side. For those that are in front of me right now, I know I went through that fairly fast, but can I have a true thumbs up or thumbs down if you understood that first step? It's just like sines. Okay, next. You ready? Make yourself a table. And we're not going to cheat the first time. We're going to start cheating after examples 3 and 4, but not the first time. Write input and output, and just like we did for sine, we're going to do steps 0 through 4. So 0, 1, 2, 3, and 4. Okay, you ready? Here we go. I want you to remind yourself that when you see these ordered pairs on the outside, if you don't have this on your cheat sheet, please write cosine and then sine. So I remember it by the acronym CVS, cosine before sine. So we are now working with a function that's cosine. I'm looking for the first number in the ordered pair. So let's locate 0, and then let's evaluate the cosine at that position. So at 0, the cosine is 1. So everybody put a 1 here. Now find pi over 2. Let's evaluate the cosine at pi over 2. At pi over 2, the cosine is 0. At 1 pi, the cosine is negative 1. At 3 pi over 2, the cosine is 0. At 2 pi, the cosine is 1. Now, unless you've seen this shape before, it's really easy to not draw the right shape, so we're going to go through this slowly. Remember, we don't make sharp V's. We don't make sharp V's. It's going to be just like our sine, it's going to be a wave curve. So let's start right now at 0, and let's go up 1. Start at 0 and go up 1 because that's the output. This is the distance above or below the x-axis. Now let's go to pi over 2. The output is 0. Let's go to pi. The output is negative 1. At 3 pi, it's 0. And at 2 pi, it's going to be 1. So here's what it looks like. It's a wave that comes down and it goes like this. That's one cycle. So if I was going to describe this in words to kind of help you better understand, I would say this parent function is an example of hill, valley, hill. Turn to your partner, please. Give them a thumbs up or thumbs down if they can see that shape, hill, valley, hill. Thumbs up or thumbs down to your partner because not everybody sees that initially. Okay, now we are going to be lazy and we are going to copy. So we're just going to follow the pattern. So then it goes back to being 0, negative 1, 0, 1. And to the left side, 0, negative 1, 0, 1. Lucas, if I asked you to evaluate this function without a calculator, looking at the graph at pi over 2, you would say the output is 0. Maite, if I asked you to evaluate this function at negative 1 pi, what would you say, Maite? A little bit louder. Negative 1. Turning to your partner, what is step 1 always to your partner? Okay, ready? 2 push-ups if you don't say it. What is step number 1? Go. Period. Here we go. So period. How do I figure out the period? Period and x scale. If you are faster than me, then keep working at identifying those two values. The period is always going to be 2 pi divided by whatever is directly in front of the x or stuck with the x. So I'm going to divide it by pi. Well, this is really, by the way, can you guys do me a favor? Put a 1 in front of that pi. Put a 1 in front of that pi. So this is really going to be divided by 1 pi divided by 2. Oh, that looks really confusing. So what I'm going to do is I'm going to take this and I'm going to write it off to the left, or down below actually here. I'm going to write this and I'm going to write it horizontally. So I want to take 2 pi and I want to divide it by 1 pi over 2. Now, by the way, 2 pi has a 1 underneath. Who remembers what we do when we divide fractions? Do you remember that saying, stay, change, flip? Do you guys remember that from elementary school? Keep the first one, stay, change from division to multiplying, and flip the second fraction. Guess what happens to the pi on top and the pi on the bottom? Yeah, we like to use the word cancel. Really, they're going to simplify to 1, but they disappear, right? Our next thing we're going to do is we have 2 times 2 is 4, 1 times 1 is 1, so this gives me 4. The period is 4, not 4 pi, because the pi's have disappeared. They've simplified into 1. They've canceled out, if you like to think of them like that. So the period length is 4. What does that mean? After 4 steps, 1, 2, 3, 4, I'm at a distance horizontally of 4. Now, how do I figure out the x scale? I take whatever my period length is, and I always divide it by 4. In this case, I get 1. That means from one step to the next is a distance of 1. So this is going to be 2, 3, 4, 5, 6, 7, and 8. Can you turn back to your partner? Whoever's shorter, are you ready? When I say go, you have 15 seconds. Your partner went to the back, and they came back, and they're like, why are we not attaching a pi underneath the 1, 2, 3, 4, 5, 6, 7, 8, and the negative 1, negative 2, negative 3, negative 4? Tell your partner, why are we not attaching pi? Because we're so used to doing that. Go. Okay, next up, make yourself a chart here. We got inputs and outputs. And I'm going to do steps 0 through 4. 1, 2, 3, 4. Now, as you start recognizing this pattern, turn to your partner. What are the 2 options we have for patterns? Like, I'm using my arms right now. That's one option. Here's the next option. Turn to your partner. What are the words we can use that are land formations? It is what? Hill, valley, hill, or valley, hill, valley. Once you recognize that pattern, you can cheat. If you don't recognize the pattern, you got to do all the work. Okay, you ready? So I'm going to show you how my mind works because I like to get the answer right but do the least amount of work. Anybody else like that? Only like 3 of you. Man, you guys are hard workers. Okay, ready? Here we go. So I'm going to substitute in 0. Now I know that when I substitute in 0, I don't care whatever is here. 0 times whatever this value is going to be 0. So let's evaluate the cosine at 0. That's step number 1, evaluating the cosine at 0. So I find 0, and I know the cosine is the first number, so this is 1. This portion, when I substitute in 0 for x, is 1. 1 times negative 3 is negative 3. Okay, you ready? If you're taller, based on this output, turn to your partner and whisper, because I don't want every group to hear. Do you think, and only the taller person can say it, and if they're wrong, they're wrong. Do you think this is an example of valley, hill, valley? Or is this an example of hill, valley, hill? Turn to your partner based on that one answer. Go. No? Do you know? Okay. What do you think, Chris M? He thinks valley, so valley is low. So low, high, low. Why do you believe that? Because it's negative, yeah, simple as that. So let's go down at 0. We have an output of negative 3. So honestly, I'm going to be real with you. At this point, I would cheat. I know the next one is going to be 0, and then I'm going to go up 3. 1, 2, 3, and then I'm going to come back, and then I'm going to go back down. So it's going to look like this. So I have to come back over here and fill this in. That's a 0, a 3, a 0, and a negative 3. Now, if you weren't sure of that, you could plug in each one of those inputs and you would see you're going to get the exact same output. Let's continue to copy it to the right. So now I have to go back up to 0, up top, 0, and down below. Jimena, can you tell me, at 3, what is the output for this particular function? 0. Good job. Blanca, can you tell me what is the output at negative 2? Good. 3. Good.